Step 2, 2006, question 1, which is quite a nice question to choose. So, the sequence of real numbers u1, u2, u3 is defined by u1 equals to 2, and un plus 1 equals to k minus 36 over un. And we don't know what k is. Okay, well, k is a constant, I suppose. Okay, so, part 1. Determine the values of k for which the sequence star is constant. Okay, what does constant mean? That means that un equals to what? Equals to un plus 1. Okay, well then this is trivial, right? This becomes trivial, I suppose. So you know u1 is 2, right? And so everything in there has to be 2. Everything, right? So you just go, okay, well 2 equals to this, right? 2 equals to k minus 36 over 2. Then you could deduce that k equals to 20. Okay, this one's trivial, right? That's trivial. We're going to ignore that. Okay, now how about part B though? So part B is saying that, okay, how about if it's periodic with period 2? Okay, what does that mean? So I'm saying that u1 equals to 2 and u3 equals to 2 and so on, right? All the odd number terms equals to 2. And, well, what is u2? What is u2? Well, I don't know. That's the thing, right? I don't know. I have to make it happen. Yeah? Okay, so let's do this. So I'm saying that, okay, u3 equals to k minus 36 over u2. Yeah, just by chucking in n is 2. Yeah. And I know, what do I know about u2? I know u2 is k minus 36 over k minus 36 over u1. And what do I know u1 is? 2. Right? I know u1 is 2. Okay, and I also know u3 is 2, right? I also know u3 is 2. Okay, so now I have, well, I have to solve the equation. So 2 equals to k minus 36 over k minus 18. Yeah, and then just do the algebra properly. Equals to k squared minus 18k minus 36. Yeah, hopefully that's okay. Well, the 36 cancels nicely. So k squared minus 20k equals to 0. Okay, so now you gotta take care. Right, k is either what? Is either 0 or 20. Okay, so we get a solution which is also a constant function. Would that be, as we expect? Would it be a thing that we expect? Well, yes, right, because constant functions are, in some way, also periodic with period 2, right? So we will expect a solution there. Okay, so the solution we like is k equals to 0, 1, right? So we're saying that un plus 1 equals to, what is it called? 0 minus 36 over un. And just as a sanity check, if I chuck, let's say u1 and u2, okay, so I'm saying u2 equals to minus 36 over 2, which is minus 18. We agree with that? Yeah. Okay, now what is u3? Just to check, right? u3 is minus 36 over minus 18, which is indeed 2. Happy days. Okay, let's just check u4 as well. So u4 equals to, again, minus 36 over 2, which is minus 18. Okay, so u2 equals to u4, which means that we're happy. Yeah, we're happy. Okay, good. Now, how about part C though? Periodic with period 4. Okay, it's sort of the same approach, right? Sort of the same approach. Let's do that. So, this is going to be slightly more annoying though, because you get a massive equation in general, right? So I need a u5 equals to k minus 36 over u4, and so on, right? I'm not going to write everything, but 36 over k minus 36. How many 36s do I actually need? Maybe 4 of them, right? Over k minus 36 over k minus 36 over u1. I suppose the equation should look like that. Okay, hopefully that's okay. Alright, so what have we got? So I want u5 to be 2 as well, right? I want u5 to be 2 as well, and I know u1 has to be 2, right? That's by definition. So, how do I do this properly? Well, I actually don't know how to do this in an effective manner. Okay, let's sub in the numbers before we do anything. So k minus 36 over k minus 36 over k minus 18. Okay, what would be a sensible thing to do? Okay, let's multiply both sides by this thing, shall we? That sounds like the most sensible thing to do. Or perhaps get the k minus 2 to the other side before we do anything. So 36 equals to k minus 2 times that thing. Okay, hopefully we're all happy with this. Yeah, hopefully. Okay, did I miss out one of the 36s? Yes, I did miss out one of 36s. Okay, so this should be, my 36 over k minus 18. Okay, I did miss out one of the 36s there. Okay, so I should have here 36 over k minus 18. That's even more annoying. Okay, well, and then I have to do the same thing again. Well, I just try my best, right? I just try my best. So I have, what are we got now? So 36 minus, okay, let's do it the other way around. K times k minus 2 minus 36 equals to 36 over, okay, this thing now, right? This thing. Okay, so this is a k minus 36 over k minus 36 over k minus 18. Okay, now this time I hope I haven't missed out a 36 there. Okay, this is just annoying algebra, right? Okay, what do we do next then? Well, you just put this to the other side and you just do the same thing. Okay, you do the same thing, fine. And then, okay, I can't be asked to finish the rest of this, but you'll get some values of k, right? Of which some of them will be valid, some of them won't. Okay, and definitely you will get 0 and 20 as solutions as well, right? For reasons that I've talked about before. Okay, so after you get different values of k, check if it works. Okay, check if it works. All right. So because the question says values of k, so there might be two values. I don't know, right? Because I haven't finished algebra, but you could do that yourself, right? Do the algebra and check if every single value of k is valid. Okay, always check. All right, let's move on to part 2. In the case k equals to 37, show that un is greater or equal to 2 for all n. Okay. For all n, what does that suggest to you intuitively? Whenever you see for all n in a question, induction, right? It has to be. Okay. So we start from 1, right? So is u1 greater or equal to 2? Well, yes, by definition, right? Because u1 is exactly 2. Okay, now we do the induction step, right? Induction. Suppose un is greater or equal to 2. Okay, suppose. Then what we're suggesting, we know that 36 over un is what? Is less than or equal to 18, right? Just by, 36 divide both sides, yeah? Okay, so now I take a negative of that. It's greater or equal to minus 18. Okay, and I need to take the k is 37, right? K is 37. So I have 37 minus 36 over un is greater or equal to what? 19. Okay, i.e. what? I.e. this thing is just un plus 1 itself, right? So this implies that un plus 1 is way greater than 2. Okay, so by induction, that's well true, right? That's well true. Okay, so that's done. Now, last bit. Given that in this case, the sequence star converges to limit L, find the value of L. Okay, what does that mean? If it converges to some limit, that means that un plus 1, well, technically you should write this, right? The distance converges to 0, right? So i.e. these two things are all L. These two things are all L, right? So let's go back to the question. Let's use some space up here. So I think it's just a quadratic, right? So L equals to 37 minus 36 over L. Okay, well, what is an obvious solution to the equation? Well, L equals to 1 is an obvious solution to the equation, right? But is that a correct solution? No. Why is that not? Because un is greater or equal to 2 for all n, right? Well, then how on earth are you supposed to converge to 1? You're nowhere near 1, right? You're bound below by 2. You won't get to 1 anywhere. Right? What's the other trivial solution? 36, right? So this is a sensible solution, right? 36 is much more sensible. Okay? So the value of L has to be 36, and we reject 1. Okay? We reject 1. Good. That's a lovely step 2 question. It's a nice one to choose as well, because it's question 1, right? So you always choose question 1. Life advice. Okay, cool.